Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0105-1C indicates an issue with the Manifold Absolute Pressure (MAP) sensor. The MAP sensor is critical in measuring the pressure within the intake manifold, which helps in assessing the engine load and optimizing fuel delivery and ignition timing. This sensor is typically located on or near the intake manifold and plays an integral part in the powertrain control module (PCM) operations. If the PCM detects an out-of-range voltage from the MAP sensor, it triggers this DTC to indicate potential failures within the sensor or its associated circuits. Understanding this error is crucial for effective troubleshooting and ensuring optimal engine performance. The Manifold Absolute Pressure (MAP) sensor's primary role is to provide accurate readings of the intake manifold's pressure to the PCM. This data is crucial for the engine management system, as it assists in calculating the proper air-fuel mixture for combustion. Typically, the MAP sensor is situated on the intake manifold to directly measure the pressure. When the voltage signal from the MAP sensor falls below 0.29 volts or exceeds 3.66 volts, the PCM identifies this anomaly and records the DTC P0105-1C. Diagnosing this issue promptly is essential to maintain engine efficiency and performance, while preventing long-term damage to engine components. There are several potential causes for DTC P0105-C. Firstly, a faulty MAP sensor can lead to out-of-range voltage outputs, triggering the error. Wiring issues, which might include frayed wires or bad connections, can also cause voltage discrepancies. Furthermore, if the PCM itself is damaged or malfunctioning, it may misinterpret the sensor signals, leading to this DTC's activation. Each of these possibilities must be investigated thoroughly to accurately diagnose the problem. Addressing these issues ensures proper engine management and performance. Drivers may experience several symptoms linked to DTC P0105-1C. Common indications include poor engine performance, characterized by power loss or hesitant acceleration, which may occur because the engine is not receiving the appropriate air-fuel mixture. Additionally, drivers might notice unusual idle characteristics, where the engine RPM fluctuates or the engine struggles to keep running at a stable idle. Furthermore, the check engine light illuminating is a common symptom that prompts drivers to seek diagnostic services. Identifying these symptoms early on can help prevent more severe engine issues in the future. In the first step of troubleshooting DTC P0105, begin by ensuring that the MAP sensor connector is disconnected. With the connector removed, turn the ignition switch to the on position to enable the vehicle's electrical systems. Using the HDS or Honda Diagnostic System, check the MAP sensor's voltage output. The normal voltage output should be approximately 5.0 volts with the ignition in the on mode. If the voltage readings deviate significantly from this range, corrective measures must be taken. This process helps pinpoint whether the MAP sensor itself is functioning correctly or if further investigation into related components is necessary. The second troubleshooting step involves jumping the MAP sensor connector terminals number 1 and number 2 using a jumper wire after ensuring the MAP sensor connector is disconnected. Once this connection is made, turn the ignition switch to the on position again to enable the system for testing. At this point, recheck the HDS for the MAP sensor voltage. The voltage should now be less than 3.66 volts under these conditions. If the output voltage meets this criterion, it indicates that the issue likely resides within the MAP sensor. If the voltage is still outside expected values, the focus should shift to potential problems in associated circuitry. The third troubleshooting step focuses on inspecting the VCC1, PB, and SG1 circuits to identify any potential faults. Ensure that both the MAP sensor connector and the PCM connector B are disconnected. Measurement of wire resistances should be taken to confirm the circuit integrity. For each circuit, the resistance should show less than 1 ohm when switching the ignition off, indicating there are no open circuits. Moreover, verify that the PB circuit is not shorted to ground by checking that resistance is greater than 1 megaohm. If any of these conditions are not met, the wiring may need repairs, as these could lead to inaccurate sensor readings or DTC P0105-1C activation. The final troubleshooting step involves performing a thorough inspection of the PCM itself, after confirming all previous tests returned normal readings. If the other inspection items indicated normal operability, yet the DTC persists, it is probable that the PCM is at fault. Use diagnostic tools to assess the PCM for any errors or malfunctions. Additionally, conduct final tests to verify if the PCM can correctly interpret the signals from the MAP sensor. If the PCM is confirmed to be malfunctioning, it should be replaced or repaired accordingly to resolve the DTC P0105-1C, restoring proper engine operation. After completing the repairs associated with DTC P0105-1C, the final verification step is crucial to ensure the system operates correctly. Begin by rechecking the MAP sensor voltage to confirm it is within the specified range defined by the manufacturer. Following this, clear any DTC codes from the PCM using appropriate diagnostic tools to reset the system. Finally, take the vehicle for a test drive to confirm proper engine performance and to ensure that issues related to the initial DTC have been resolved. If no new DTC codes appear during or after the test drive, it indicates successful repair. Preventive maintenance is vital in avoiding future issues related to DTC P0105-1C. Regular inspections of the MAP sensor and its wiring should be part of routine vehicle maintenance. Checking the integrity of the wiring for any signs of wear, fraying, or damage can address potential circuit faults before they result in DTCs. Additionally, monitoring engine performance through regular diagnostics can help detect issues early. Maintaining clear communication between the PCM and the MAP sensor through consistent checks ensures optimal engine operation and longevity. In conclusion, understanding DTC P0105-1C is crucial for maintaining the efficiency and performance of a 2023 plus Honda CR-V. The MAP sensor plays a vital role in engine management, and deviations in its voltage readings can lead to significant performance issues. Monitoring these voltage ranges and promptly addressing any anomalies is essential. Thorough diagnostics should be carried out, following the laid-down troubleshooting steps to identify potential causes accurately. By following the appropriate repair and maintenance practices, drivers can enhance the reliability and longevity of their vehicles, ensuring they remain in peak operating condition. Please like and subscribe to the channel. See you next time.